it. You'll see later on how we're actually going to use it. We're not going to be drawing all of these lines of triangles and stuff. Okay, the triangles are just there to try and to understand the concept and why we are allowed to work with these things. First, before we read through these notes, I would like us to take our calculators out, please. We're going to do a little investigation. Okay, and I'm going to write this down. You don't have to write it down if you don't want to. It's fine. We're just going to work off the notes. But I just want you guys to notice something. Sorry, it is quite zoomed in now because this note is so small. Okay, in the calculator, I want you to type the following values, or type the following things and see what you get. Okay, I'm also just going to do it. I think most of you have gotten that far. Right, sine of 30 is a half. Guys, do you remember with your special triangles that you learned last year? And we also summarized them again at the beginning of Trig when we started. You actually should be able to do this without using a calculator, right? You are supposed to know, just going to do it a rough sketch here on the side. You are supposed to know that this is your 30-60 special triangle. Oh, it's smudging. Sorry about that. Right, so you have your 90-degree angle, you have your 30 and your 60, and you have 1, 2, and √3. Right, this you need to be able to draw just like I did now. Okay, quickly out of your head like that. Then you need to be able to use this triangle to read off the various trig ratios. So you need to remember that sine is opposite over hypotenuse. So they're asking for sine of 30. Well, I am asking for sine of 30. So you're going to look at the 30-degree angle. What side is opposite the 30-degree angle? 1 over the hypotenuse, which is 2. Okay, so I know we typed it into the calculator now because we can't really use this triangle for these values. Okay, but in a normal test or exam, if they say you need to find these values without the use of a calculator, that is how you would do it. Okay, you would draw your special triangle that you have to know off by heart, and then you'll read it off from there. Now, guys, if we're doing the next ones, sine of 180 minus 30, what is 180 minus 30? 150, hey? So we could have just typed in 150. Do we see that we're getting the same value? Okay, that is also positive a half. If you want to, and I see that most of you guys did actually copy this down, it's fine if you didn't. If you did, you can just put a 150 there above that because 180 minus 30 is 150. Right, I'm just writing it in that way so that I can show you something. Okay, it should make sense just now. Then if we do sine of 180 plus 30, what is 180 plus 30? 210, right? So we could have actually just typed in sine of 210. We're getting negative a half. Okay, so the same value, but a negative answer. Okay, that's interesting. We can discuss that now. Then if we're doing sine of 360 minus 30, which is, what is 360 minus 30? 330, so we could have just typed that in as well. All right, if we type that in, we are getting, again, negative a half. Now, why do you think that we are getting different signs for these values here?
Because sine is only positive in the first two quadrants, but it's positive
Yes, did you guys notice that the first value that I gave you, 30 degrees, that angle would be in the first quadrant, right? Remember the first quadrant has angles between 0 and 90 degrees. If you want, you can, I wonder, is it printed on this note? No, it's not. Let me just see. No, it's not. We can write that down. Right, we're going to do our cast diagram. And guys, it's very, very important that you know this cast diagram. Okay, it's going to help you a lot with all of these questions. So that would be 0. We know that here we have 0 degrees. I think we might have written this down when we actually did the cast diagram in that first note, but now it's going to become very important. There we have 90 degrees. All right, so do you see what I'm saying? Any angle in the first quadrant is between 0 and 90. Okay, we know that this is quadrant 1. Any angle between 0 and 90 is in the first quadrant. So sine 30 degrees is in the first quadrant. So that is why sine of an angle in the first quadrant is equal to a positive value. All right, positive a half in this case. 180 minus 30, that is in the second quadrant, right? 150 degrees, because this is 90. That over there is going to be 180 degrees, right? It's a straight line. Angles on a straight line is 180 degrees. So any angle between 90 and 180 is in the second quadrant. So 150, for example, that is between 90 and 180, right? 150 degrees does lie in the second quadrant. And what is sine in the second quadrant? Can we remember? Positive, hey? Remember, cast diagram, I'll put my C and my A and my S and my T. That's how it works, right? So in the first quadrant, all of the trig ratios are positive. In the second quadrant, sine of any angle in the second quadrant will be positive. Now we're actually seeing that, right? Sine of 150 is positive a half. If you took cos of 150 or tan of 150, it would give you negative values. I'll just show you that quickly. Cos of 150, now it's also going to be a different value, okay, because it's not sine now, it's cos. But do we notice that it's negative there? All right, cos of any angle in the second quadrant, we've used 150 now, but it can be anything between 90 and 180, will be negative. And also tan, if we're doing tan of 150, that is also giving us a negative answer. Okay, that's how the cast diagram works. That's where it comes from, basically. Then sine of 180 plus 30. Remember, if we're going around with our angles, this is 180 and this is 270. So any angle between 180 and 270 will be in the third quadrant. Now, do we all agree that 210 is between 180 and 270? Right? 210 is between 180 and 270. So 210 is in the third quadrant. And guys, sine is supposed to be negative in the third quadrant. And we actually saw that when we typed that into the calculator. We're getting a negative answer there. Does anyone know why we'll get a negative answer? How do we calculate sine again? Sine is always opposite over hypotenuse. If I was to draw a triangle here, a right angle triangle there, isn't my opposite side going to be negative? Right, because it's on the negative side of the y-axis. Okay, so you see we're kind of putting everything together here. Let me just erase this. That is actually why sine is negative in the third quadrant, because your opposite side is always going to be negative in the third quadrant. All right, then 360 minus 30, 330 degrees. This is not only 0, but that is also 360, right? If you go all the way around, you end up at 0, but you also actually end up at 360, all right? It's the same place. So any angle between 270 and 360 is in the fourth quadrant. So 330 would lie in that quadrant, right? 330 is between 270 and 360. And we do see that if we take sine of that angle or any angle in the fourth quadrant, guys, I've just used a similar angle in all of these. I'll explain now. We get a negative answer, right? And that is for the same reason as why we get a negative answer in the third quadrant, because if I was to draw my triangle here, right, my opposite side again will be negative. Okay. Now, guys, reduction formula is a way of literally reducing an angle, all right? Any angle that is not an acute angle, we can reduce it to an acute angle using reduction formula. Okay, so what did we see here? The value of sine 30 is a half. If we take, for example, sine of 330 degrees, let me write it here at the bottom. For example, if they're asking you to find the value of sine 330 without the use of a calculator, right, and we are going to get to that, so we're going to do lots and lots of examples. You can rewrite 330 degrees as 360 minus 30. Right, doesn't that mean the same thing? 360 minus 30 is 330, right? And then using reduction formula, which we are going to practice a bunch, so don't worry if it's a bit confusing. We're going to say, okay, 360 minus 30 degrees, what quadrant is this in? What quadrant is 360 minus 30 in? It's in quadrant 4. Then you're going to ask yourself, what sign does sine have in quadrant 4? Is it positive or is it negative? Negative. So we are going to reduce this whole angle, which is 360 minus 30, to negative sine of 30 degrees. So we're changing the whole angle of 330 to 30 degrees, but in order to do so, we have to make the actual value negative because sine is negative in the fourth quadrant. Okay, I'm expecting you guys to be a bit confused, so don't panic if you are. All right, now we're just going to understand or find or know that the value of sine 30 is a half, so this is going to be negative a half. All right, this is what we're working towards, guys. This is what we're going to use reduction formula for. It is a way of rewriting angles that are not acute as angles that are acute, and then finding those values. Yes. So we can also do negative angles. We'll get to that later still, yeah, but at the moment we're just going clockwise. Guys, do you remember when we did these triangles? Let me just show you quickly. I said to you that we are going to use the small angle in the triangle as theta when it actually isn't. Does that ring a bell? Show you quickly. And this is not actually why. Remember when we did this one, we said that this angle theta has to actually lie in the fourth quadrant, all right? But in our triangle, we used the acute angle as theta when actually it wasn't equal to theta, all right? So we're going into the explanation of why we could do that. Okay, I am still going to get to that. Let's look at these notes quickly. Let's look at how they've summarized it here because this is a more general summary. They basically did the same thing that I did, but they've worked with 60 over here. So they're saying reduction formula are used to reduce an angle greater than 90 degrees, to an equivalent ratio of an acute angle. Now what they say when they mean when they say equivalent ratio, they're talking about this half, right? Because all of these sine ratios here, they all are equal to the value of a half, but they have different signs. Okay, so that's what they mean when they say equivalent ratio, the ones that will give us the same actual answer. So maybe we just want to highlight that, guys. Let's see if the pink is going to work. Going to reduce an angle greater than 90 degrees to an equivalent ratio of an acute angle. Okay, so like I said, we are taking angles that are bigger than 90 degrees, angles that are not acute, and we're rewriting them as acute angles. Okay, that's what we're going to use reduction formula for. Then they're also saying there we are going to get to negative angles only tomorrow probably. We can also change a trig ratio of a negative angle to an equivalent ratio of a positive angle. Okay, so we will still get to that tomorrow. Here they're talking about the 180-360 rule. Okay, now we have kind of looked at it already. They're saying refer to the diagrams alongside each example. If we're looking at sine, in the first quadrant, they're asking us for sine 60. All right, so there they've drawn a triangle with a 60-degree angle and a 30-degree angle. It's basically the one that I just drew, this one over here. They've just swapped the 60 and the 30 around. Okay, so that's why it looks a bit different. But there they have that triangle. Guys, if they ask me for sine of 60, you're going to say opposite over hypotenuse. Is that fine? Root 3 over 2. Okay. If you have sine of 180 degrees minus 60, this is actually 120. Right? So now we see that that is the angle that we're moving, right? We're going from 0 to 120. But guys, what is the angle that is then left in order to get to 180 degrees? 60, hey? Right, so if we are going from 0, from our x-axis here, and we're moving 120 degrees, the reference angle, that's what they call it, usually the acute angle in the actual triangle is going to be 60. All right, which is kind of what we did when we used theta. Okay, we said that that is theta, so then I'm going to say that that is also theta. All right, it's difficult to see, I know. This, if you type it into the calculator, sine of 120 is going to be equal to root 3 over 2, which is the same as sine of 60. All right, it's basically what we just did now. Because sine is positive in quadrants 1 and 2. Let's look at something different, something that we haven't looked at before. We're looking at cos. Now, guys, what do we know about cos in the second quadrant? Cos in the second quadrant, is that positive or negative? Negative. Okay, and we can see it here in this example. Cos of 60 is a half. That's if we're working in the first quadrant. Now, if we have to do cos of 120, 120 is the same as 180 minus 60. Which is what they put in brackets, okay? So you can see that they've drawn the triangle here. We're going 120 degrees, meaning that the angle in the triangle, that acute angle, is actually going to be 60. Okay, now, cos of 60, if we're looking at this triangle, because now remember our x length is now negative. Now it's going to be adjacent over hypotenuse, so negative a half. Negative 1 over 2, which is negative a half. Okay. But what they're trying to show you here, they just didn't kind of pull it all together, is if they are asking you to find, write that down, please, cos of 120. You can rewrite 120 as 180 minus 60. Now you're going to ask yourself, which quadrant is 180 minus 60 in? Or 120, which quadrant is that angle in? Quadrant 2. What is cos in the second quadrant? Negative. So this is going to become negative cos 60. You're going to get the same value as cos 60, but because it's in the second quadrant, the answer is going to have to be negative. So the answer is going to be negative a half. Now, guys, on this class diagram, I want you please to just write in your first quadrant somewhere that theta, whenever you see the angle theta or x or whatever, we assume that that is an acute angle. Okay, so from now on, whenever you see theta, we assume that it's an acute angle. If they want it to be an angle that's not acute, they will have to state that. Okay, so theta is always acute unless stated otherwise. Now, an expression that will always give us an angle in the second quadrant would be 180 minus theta. 180 minus an acute angle will always give us an angle in the second quadrant. I'm going to say that again. Remember, theta is acute. Okay? If you take 180 minus any angle that is acute, any angle that's smaller than 90, it will give you an angle in the second quadrant. So if you take, for example, 180 is here, right? So we're at 180, now we minus 60 from it, right? 180 minus 60 is going to be at 120. That's still in the second quadrant. If I take 180 minus 10, what's that? 180 minus 10 is 170. Which quadrant is that in? Still quadrant 2. 180 minus 30 is 150. Where is that? In the second quadrant. All right, so this 180 minus theta, whenever you see that, you need to think immediately that is in the second quadrant. Yes. Yes, so 90 plus, they have different rules. We are still going to come back to that. But yes, 90 plus theta will also get you an angle in the second quadrant. Yes. What do you guys think? How can we express an angle in the third quadrant always using theta, using an acute angle? Jack, do you want to try? 180 plus theta, good. 180 degrees plus theta, that will always give us an angle in the third quadrant. So whenever you see 180 plus theta or x, or just an acute angle, that will land you up in the third quadrant. And what about quadrant 4? 360 minus. We can also work with 270, but that also has a different rule. Okay, so for now, and that's why they're saying in the note, the 180, 360 rule. Okay, so we're just looking at those for now. 360 minus theta will always get you an angle that is in the fourth quadrant. Please highlight those, guys. That theta, the 180 minus, the 180 plus, and the 360 minus. Please, Robert. Yeah, we're just not going to do any examples of that just yet, but yes. I'm just underlining them because it's going to smudge if I highlight those. Okay, that's very important, guys. Now, I know you're very confused at the moment. I'm not going to go through the tan stuff because it's just more of the same. I actually want us to look at the second page quickly. You can look through the last couple of triangles there if you want. But this is what we're actually going to do. I just want to do an example of how these questions will actually be asked. Okay, because they're not going to ask you to draw those triangles necessarily. So to summarize, this is important, guys. Please underline that or highlight that. That's what we're going to do each time. Determine which quadrant the angle is in. If they've given you a numerical angle, you will know which quadrant that is in, right? If they've given you 150, you should know that that is in the second quadrant. Or they're going to give us these expressions, and we need to then identify if it's 180 plus theta, it's going to be in the third quadrant, and so on. All right, that's going to be your first step. Like I did here, guys, I wrote there, quadrant 4. That was my first step. I just identified which quadrant it's in. Then decide whether the ratio is positive or negative in that quadrant. So like I said here, okay, sine in the fourth quadrant is negative. That's the second step, right? The angle then becomes the acute angle. So what we did here, where we had 330 degrees, all right, I rewrote that as 360 minus 30. And then what did I change my angle to? 30. That's what they're saying, right? The angle, the original angle, which was 330 degrees, I put the minus in front, and then this angle becomes the acute angle. Okay, we're going to look at some algebraic ones now. Those are actually a bit easier than the numerical ones. We'll come back to the numerical ones afterwards. I want us to actually write down the worked examples that are on the note. All right, so just write their worked examples in your book. I think once you see how you're actually going to have to answer these questions, you might feel a bit better. Yeah. Yeah. Yeah, but that's why I'm saying it's different, because then you're actually going to have to change to cos. So with 90 and 270, you don't just change the angle, you change the sine and all the cos as well. Okay. Yeah, just, yes, yeah, for now. Okay, guys, just write this down quickly, please. I just want to get through this before we have to go. Okay, we have to simplify that. Now, guys, in this case, we're not working with theta, we're working with x instead of theta. All right, so x represents an acute angle. Do we notice that all of these angles that we've been given are angles that are bigger than 90, right? Because if we have 180 plus an acute angle, that is definitely an angle that's bigger than 90. All right, and if we have 360 minus an acute angle, that is also an angle that is bigger than 90. So all of these angles are bigger than 90. We want to write them in terms of just x. We don't want the 180 plus and the 360 minus and so on. We just want x's. And guys, the reason for that is if I have this is cos x and that is cos x, then I can cancel them out. All right, where if they're written in the way that they are here, cos 180 plus x and cos 180 minus x, I can't cancel them out. Okay, they are different things. So that's why we want to reduce those angles to just x's so that I can actually cancel them out going forward. Okay, Jasper, can you just press pause on your question? Put your hand up. All right, 180 plus x. Which quadrant is that, guys? 180 plus x is in quadrant 3. Please just write that above the bracket there. What is cos in the third quadrant? Let's do our little cos diagram here on the side. Cos in the third quadrant is negative. So this is going to become negative cos x. We're going to take away that 180 plus. But in order to take away the 180 plus, we need to take the sign of cos in that quadrant. Okay, so I have my 3 here. I'm now going to change cos of 180 plus x to negative cos x. And that's all you have to do, guys. That's how we're going to use reduction formula. Step 1, you identify which quadrant the angle is in. 180 plus x is in the third quadrant. Then you ask yourself, what is cos in the third quadrant? It is negative. So we change it to negative cos x. That's the third thing where they said the angle becomes the acute angle. So 180 plus x just becomes x. Okay. Times 360 minus x. Which quadrant is that? Quadrant 4. Yeah.
I'm very confused about how we can take out 180. What does 180 represent with regards to quadrant?
So that's what we did there. All right. That sine of 180 plus 30 was actually the same as negative sine 30. We got the same value. Okay, guys, can we look at that? Sine 30 is a half, right? So when we took sine of 180 plus 30 and we typed it into the calculator, we got the same value as negative sine 30. So that is how reduction formula work. You basically cancel out the 180 plus by replacing it with the sign in that quadrant, whether it's positive or negative. Robin? Yep, will work for any number. All right, in this case, we work with using x, but it will work for 60, it will work for 20, for 10, for any number. Because guys, if you're thinking of drawing a triangle in these quadrants, right? If you have a 30-degree triangle here, it will have the same values as a 30-degree triangle there. One of the sides will just be negative. It will have the same values as a 30-degree triangle here. That side will just be negative. It will have the same values as a 30-degree triangle there. That's why we can use the same exact values. We just have to change the sign of the ratio. Okay, you guys are packing up already. Oh, it is time to go. Can you just, for homework, please just read through. This is the example that we wrote down now. Okay, please just read through example 1, copy it into your books, please. In the blocks, I've put an explanation of every single thing that's being changed there. Okay, so read through that. We're going to do example 2 in class tomorrow. All right, thanks. You can go.